Good morning, students. I am Pramod Joy, your computer science teacher, and this is our new topic, number system. And this is in connection with that unit number 1, computer systems and organization. In that computer system overview, we discussed Boolean logic, we discussed, and this is the third topic, number system. And this is my sixth video related with the unit number 1, computer systems and organization. One more video is the related with the unit number 1 and in connection with number system. And in this chapter, in this topic, I am going to explain to you about the number system. There are four main number systems we use, and they are decimal number system, binary number system, octal number system, and hexadecimal number system. Decimal number system. Decimal number system contains maximum 0 to 9 numbers, including both 0 and 9. That means the base is 10. Base is 10 in the sense the total number of digits in the decimal number system is 10, 0 to 9. And it is written in a special manner. An example is given below. For example, 45 is written in a decimal number system. So you have to write like this, 45 to the base 10. Now the binary number system, binary number system, which contains only two numbers, 0 and 1. So the base is 2. That means only two numbers are there. So the base is 2. And an example is given below. 100,110 to the base 2. That's an example for a binary number written in binary number system. Octal number system. Numbers between 0 to 7. Total numbers, that means the base is 8. And an example is given below, 45 to the base 8. Hexadecimal number system. Numbers 0 to 15. That means 0 to 9 and A to F. A to F in the sense 10 can be also written as A, capital A, and 11 can be B. Like that 15 can be written as F. Base is 16. Total 16 members are there. An example is given there. 1AB to the base 16. So 1AB means 1, 10, 11 to the base 16 actually. Now the conversion. The very first conversion, decimal to binary. How to convert a decimal number to binary number system. An example is given here. Convert 45 to the base 10 to binary. And it is done by continuous division. Here you can see the division. 45 is divided continuously, and the right side the remainders are written. In this case, 45 is divided by 2. So it gives the answer 22, because 22 into 2 is 44 and the balance is 1. So the remainder or the balance is written 1. Now the 22 is again divided by 2. So 11. 11 into 2 is 22. So the balance is 0. Then 11 is again divided by 2. So 5. 5 into 2 is 10. So balance 1. Again the 5 is divided by 2. So 2 into 2 is 4. It is not exactly divisible, so the balance is 1. Again 2. It one time. 1 into 2 is 2. So there it stops. And it is written in such a manner that means it should start from the last to 1. You can see that 45, 22, 11, 5, 2, 1. From that 1 you have to start. So 1, then the remainders from the last. 1, 0, double 1, 0, 1. Like that you have to write. So 45 to the base 10 is equal to 1, 0, double 1, 0, 1 to the base 2. Now suppose if it is a fractional number, for example, 45.25 to the base 10 to binary. We already know how to convert 45. Now how to convert this 0.25 to the base 10 to binary? Here you have to multiply it. Multiply it with 2. Why to 2? Because we have to convert to binary and the base of binary is 2. That's why we are dividing or multiplying by 2. So 0.25 multiplied by 2, that is 0.50. Out of that, the integer part is written the 0. Again, the fractional part is taken again. 0.50 again multiplied by 2. Here you are getting 1.0. So again the integer part is written there and fractional part is taken. Here there is no need to take the fractional part because you are going to multiply 0 into 2. So till that point you have to continue till that fractional part gets 0, or minimum 5 numbers you have to continue, or minimum 5 sections you have to continue. So 45.25 to the base 10 is equal to 101101.01 to the base 2. Now converting a binary number to decimal. An example is given there. Convert 10110 to the base 2 to decimal. So here we have to multiply it with 2. We are converting a binary number to a decimal number, and we have to multiply that binary number with 2. Again, I told you the reason. Since the base is 2. So 1 into 2 raised to 5 plus 0 into 2 raised to 4 plus 1 into 2 raised to 3 plus 1 into 2 squared plus 0 into 2 raised to 1 plus 1 into 2 raised to 0. And the answer gives 45. 45 to the base 10. And now a fractional number. Convert 101101.01 to the base 2 to decimal. So how to convert 0.01 to decimal? So here you can see at the end of that, it's 0 into 2 raised to minus 1 and 1 into 2 raised to minus 2. The fractional part is converted in such a manner. And the answer is 101101.01 to the base 2 is equal to 45.25 to the base 10. Decimal to octal. How to convert a decimal number to an octal number. Earlier we saw how to convert a decimal number to a binary. Decimal number to binary means dividing by 2. Now decimal number to octal. So what's the base of octal? Base of octal is 8. So here divided by 8. And here you can see that example. Convert 266 to the base 10 to octal. Now 266. 266 is divided by 8. It gives the answer 33. It is not exactly divisible. Balance 2 is there. That is written at the right side. Now again this 33 is divided by 8. So 8 4s are 32. Balance is 1. Now you cannot divide 4 with 8. So there you stops. And you have to write in such a manner. That means you have to start from the 4. So 4, 1, 2. So 266 to the base 10 is equivalent to 412. 412 to the base 8. Now how to convert a fractional part to octal? For example, convert 266.66 to the base 10 to octal. Earlier we have seen how to convert a decimal number to octal, a decimal fraction to octal. We multiplied it with 2. Now here, a decimal fraction to convert to octal, you have to multiply it by 8. So here 0.66 multiplied by 8, it gives 5.28. And the integer part is written there, 5. And the fractional part is taken here. Now the fractional part is 0.28. Now 0.28 into 8. That gives 2.24. Again the integer part is written there, 2. 0.24 is taken. So 0.24 into 8. It goes on like that until we get that integer part, that fractional part as 0. Or otherwise, we have to do the first 5 sections as I told you earlier. So now the answer is 266.66 to the base 10 is equal to the octal number 412.52172 to the base 8. This slide explains the octal and hexa equivalent of the binary numbers. Now decimal to hexadecimal. How to convert a decimal number to a hexadecimal number. An example is given there. Convert 423 to the base 10 to hexadecimal. Earlier we converted a decimal number to binary, a decimal number to octal, now a decimal number to hexadecimal. In order to convert a decimal number to binary, we divided by 2. Since the base of that binary is 2. And after that, we converted a decimal number to octal and we divided it by 8 since the base of octal is 8. So now we have to divide it by 16 since the base of hexadecimal is 16. You can see that division. 423 divided by 16. The answer is 26. It's not exactly divisible. Balance is 7. Now the 26 is divided by 16. It gives only one time and the balance is 10. and it is written in such a manner, you have to start from the last number. So 1, 10, 7. In hexadecimal, 10 is also known as A. Hexadecimal number is 0 to 15, or in other words 0 to 9 and A to F. So A is 10. So 1A7 to the base 16. Now how to convert a decimal fraction to a hexadecimal number? As in the previous cases, in the case of binary, that means converting a decimal fraction to binary, we multiplied it with 2. To convert a decimal number to a decimal fraction to an octal number, we multiplied it with 8. And in this case, we have to multiply it with 16. And the answer is given below. Converting octal and hexadecimal number to decimal number system. Earlier we have seen how to convert a binary number to decimal. We have to continuously multiply it with 2. Now in the case of octal, for example, convert 372 to the base 8 to decimal. So 3 into 8 squared plus 7 into 8 raised to 1 plus 2 into 8 raised to 0. And the answer is 250 to the base 10. Now a fractional number. Convert 24.6 to the base 8 to decimal. So here we have to use that 8 raised to minus 1, 8 raised to minus 2 like that. So you can see at the end, plus 6 raised to minus 8 plus 6 into 8 raised to minus 1. And here the answer is 20.75 to the base 10. Now how to convert a hexadecimal number to decimal? An example is given there. Convert 356 to the base 16 to decimal. So here you have to multiply it with 16. So 3 into 16 squared plus 5 into 16 raised to 1 plus 6 into 16 raised to 0. And the answer is 854 to the base 10. Now how to convert a fractional number? In this case, convert 56.08 to the base 16 to decimal. And you can see that 0 into 16 raised to minus 1 plus 8 into 16 raised to minus 2. And the answer is 86.03125 to the base 10.